So again, for example 6, we're going to expand and simplify. So we have this, so x to the third, x, and x to the fifth, 3, 4, 5. And when we simplify, cancel, 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 we're left with a 1 on top and then an x squared in the denominator. So again, let's now use the quotient rule to simplify it. So for the quotient rule, we got the same base of x. We got the base of x. We take our top exponent and subtract our bottom exponent. And 3 minus 5 is -2. All right, so that implies that x to the -2 is the same thing as 1 over x squared. And so, in fact, that's what we have here, negative exponents. If we have a raised to the negative n, then we're going to keep our base. Again, you notice the base of a stays the same, but it's going to become 1 over that base of a raised to a positive n. So let's go through and do some examples. Here our base is 4 and it's raised to the -3, so that's going to become 1 over 4 to the positive 3. And we could simplify that. 4 times 4 times 4 is 64. This time my base on B is the whole parentheses. So it's the whole parentheses base raised to the -4. So when I drop it, the whole parentheses drops. It's got a -3 inside of it. And now it's going to be raised. It goes from -4. This is a positive 4. So note that when it does drop, it loses its negative sign there. And then if I were to multiply -3 times -3 times -3 times -3, I get a positive 81 over 81. C, again, the base on this one is just the y, and it's the y that's raised to the -3. So it's going to be 5 times, and then y to the -3, I'm going to drop that base of y and make it be a positive 3. So when I simplify that and multiply this out, it is 5 over y to the third for my final answer. D, I have a 4x raised to the -1. So again, the base is the entire parentheses. So the entire parentheses is going to drop, and it's going to be to the 1 power. And of course, I would simplify that to 1 over 4x. E, I have k to the 4th over k to the 8th. So I'm going to use my quotient rule and say that's 4 minus 8. So that gives me k to the -4 power. And then notice up here, it says write with positive exponents only. So from here on out, you're always going to pretty much see that. You never leave a negative exponent in your final answer. So then I'm going to then drop my base of k down and make it a positive 4 for my answer. And then F, same thing. I have a base of 2. So I'm going to do 2 minus 7 on my exponents. So that's 2 to the -5. And then I'm going to drop that base of 2 down and make it a positive 5. And 2 multiplied out 5 times is going to be 32. For G, I have 3 to the -2 plus 4 to the -1. So I'm going to simplify this. So 1 over 3 squared plus 1 over 4. So this is 1 over 9 plus 1 over 4. I'm going to add it, so I need a common denominator of 36. So that's going to be 9 going to 36, 4 times 1 is 4. 4 going to 36 9 times. 9 times 1 is 9. And then I'm going to add it and get 13. 36. And finally, I'm going to do this a long way, but this is going to be 1 over, and then x to the -4. That's going to drop my base, make it positive. So then that means 1 divided by 1 over x to the 4th, which is 1 times x to the 4th over 1. And that's going to end up being x to the 4th. So 1 over x to the negative 4 simplifies to, a lot of work there, x to the 4th. So observe, helpful hint. Notice that when a factor containing an exponent is moved from the numerator to the denominator, or from the denominator, which we did here, to the numerator, the sign of its exponent changes. So x to the negative 3 becomes 1 over x to the positive 3. 5 to the negative 2 becomes 1 over 5 squared. 1 over y to the negative 4, that negative y to the negative 4, the base moves up and becomes a positive 4. 1 over 2 to the negative 3, that moves up, and that negative 3 becomes positive 3. All right, so take a minute and try these. Stop the video, try these, and then pick it back up. I want to do a few more examples. All right, so example 7 here, I have y to the negative 11th over y squared. So I'm going to use the quotient rule. So it's y to the negative 11 minus 2. So y to the negative 13th, which is going to be, now to get rid of my negative exponent. So I'm going to then drop it to the denominator, and it becomes positive 13. Let me show you another way of doing this. Another thing that you can do is always move it across and take it up. So this is going to be 6 u to the 5th. And when this goes up here, it's going to change from a negative exponent to a positive exponent. So it's going to become u to the 3rd when I move it up. So now I've got the same base, but this time it's multiplication. And I'm then going to add those together. So u to the 5 plus 3 is going to be 6u to the 8th. So for C, again, you have your choice. You can either do it like I did this one where I did the subtraction, or you can make your exponents positive. So let's make on this one, let's make our exponents positive. So I'm going to move this up. It's going to become 3 squared. Move this down. Oh, that's 3 to the 4th. And you can kind of see where this cancels. I'm going to get 2 minus 4, which is 3 to the negative 2, which is 1 over 3 squared, which is 1/9. I don't know that I'm crazy about that. Probably what you'd want to do here maybe is negative 4 minus a minus, which gave you negative 4 plus 2, 3 to the negative 2, and then change it. Let me try and get one more in. So D, again, I'm going to take it in pieces. 3 over 12 is going to reduce by 3 so that I get 1/4. And then for my x's, I have this x here. This x to the negative 4th, I'm going to drop it down and make it positive. I have a y to the 5th up on top, and this y to the negative 3rd is going to move across and become positive. So then that's going to give me, I'm going to now add these exponents. So y to the 8th, and then I have a 4, and then x's, I have 1 plus 4 is x to the 5th. I'm going to stop there. We'll do this other one next class, but you try these down here below, and I'll see you next class.